Namaste one and all. So here we are given a function which has been defined like this. For x less than 0, we have mod of x plus 1. For x equal to 0, functional value is equal to 0. For x is positive, functional value is mod of x minus 1. Now they are asking for the values for which the limit exists. Now the function has been defined like these three segments. So we will consider the case 1 where we are taking the value of a as 0. So to say limit exists at 0, we have this condition should satisfy. This equation should be satisfied. 0 from approaching 0, x approaching 0 from left hand neighborhood equal to limit x tends to 0 plus, which is from right hand neighborhood equal to, these two are equals means we can say limit exists. So limit x tends to 0 fx exists. Now for 0 we are applying for left hand side. So from left hand side we are taking this function. So limit x tends to 0 mod x plus 1. We are substituting mod x as 0 plus 1. We are getting 1. And again limit x tends to 0 plus. For this, consider this function mod x minus 1. Substitute x as 0. So you will get 0 minus 1. Here left hand limit is not equal to right hand limit. So we are concluding limit does not exist when the value of a is equal to 0. Now the other two cases are positive real numbers and negative real number. So let us take in case 2 a as negative real number. So if a is negative, again we are checking for the left hand limit and right hand limit. If those two are equal, then we can say limit exists for a negative. Okay, so now limit x tends to a minus. Since we are taking negative real number, consider this case. Now here we have mod x. Mod x can be defined like this. Mod x will be x if x is positive, and mod x will be minus x if x is negative. So based on this definition, we can write it as minus x plus 1. After substituting limit value, minus a plus 1 we will get. So this is left hand limit. Now we will calculate right hand limit. So for right hand limit, limit x tends to a plus, since a is negative, take this expression. So for this, mod x plus 1, and again here the value of x is negative, we will have minus x according to the definition of modulus plus 1. Limit x tends to a. So after applying x as a, we are getting minus a plus 1. So here this is RHL, right hand limit. So left hand limit equal to right hand limit. So we can say for all negative real numbers, limit exists. So we'll consider about a positive. So a positive means this function mod of x minus 1. So again apply limit x tends to a plus a minus, from left hand neighborhood, function is mod x minus 1. Since that x is, these values are positive, according to the definition of mod, we can take it as x minus 1. Substituting x as a, we are getting a minus 1. For left hand limit, for right hand limit, limit x tends to a plus, again we are taking the same, mod x minus 1. So after substituting, after applying the definition, x minus 1 we are getting, so a minus 1. Again here left hand limit equal to right hand limit. So limit existing, we are able to get the limit when the values of a is positive as well as negative, but not when the value of a is equal to 0. So we can say the values of a can be any real number except 0. Thank you.